Hello friends, in today's video we are going to see bottom-up code for Fibonacci series. In my last video I have already explained top-down code, and prior to that I have explained recursive code. And if you have not watched those videos, then please go and watch those, otherwise it will be very difficult for you to understand it directly. Now come to this video. See, this is a top-down tree, and you may be thinking, why this top-down tree here? This top-down tree will help us in finding the dependency. That is, see, imagine a table 0, 1, 2, 3, 4, 5, 6. If you remember the top-down video, then at 6th index I was saving the value of fib of 6. 5th index I was saving the value of fib of 5. Now come here. Fib of 6, that is 6th Fibonacci number, is dependent on 5th and 4th Fibonacci number. Okay? 5th Fibonacci number is dependent on 4th and 3rd. Similarly, 3rd is dependent on 2nd and 1st Fibonacci number. So, what is my dependency here? That is, if I imagine it as a table, then to calculate fib of 6, I need answer of fib of 5 and answer of 4 in a correct way. That is, I need correct answer for fib of 5 as well as fib of 4. Okay? That is, suppose I am calculating nth Fibonacci number, I need correct answer for n minus 1th Fibonacci number and n minus 2nd Fibonacci number. Okay? So, how we need to fill this particular list so that our dependency will be covered. So, the answer to this is, if I will fill my table, that is this particular list from left to right, will my dependency be covered or not? The answer is yes. My dependency will be covered if I will fill this particular list from left to right. Okay? Now what we will do? We will write a bottom-up code to do the same thing for us. Now let's write the code. So def to define the function. Fib will be the function name. It will take n as parameter. After that, what we will do? We will create a table. And I am initializing it with 1. If I will initialize it with 1, my first and second Fibonacci number is 1 and I do not have to calculate it. So I am initializing it with 1. And you may think, if I will initialize it with 1, then at 0th index also it will be 1. But the question is that, do we bother about 0th Fibonacci number? Answer is no. So this is how I am filling this particular table, and if I want to deal with 0th case, then what I will do? I will just write a one-line code, that is, if n is smaller than or equal to 0, then return 0 on top of it. Okay? So this is how I am creating this particular table. Now we are going to write a for loop. For I in range 3 to n plus 1, and in every iteration I will update tab of I. Tab of I equal to tab of I minus 1 plus tab of I minus 2. Okay? And once this for loop will be done, I will return tab of n from here. Now let's see how this code will execute for n is equal to 6. That is, we will calculate 6 Fibonacci number. So first of all, what will happen? This table will be created and it will be initialized with 1. Everything will be 1 here. So as you can see here, at first and second index, that is the index which will be representing first and second Fibonacci number, I already have 1. So do I need to calculate it? No. So I will start from I equal to 3, that is third Fibonacci number. So this particular for loop, if n will be equal to 6, will execute for I equal to 3, 4, 5 and 6. Now see what will happen when I will be equal to 3. When I will be equal to 3, in tab of I, that is tab of 3, I will update tab of I minus 1, which is tab of 2 plus tab of I minus 2, that is tab of 1. This one is equal to 1, tab of 2 is equal to 1, and tab of 1 is equal to 1. So it will be equal to 2 and it will be updated here. Okay. Then for I equal to 4, it will run, and in tab of 4, tab of 3 plus tab of 2 will be updated. Tab of 3 is 2 and tab of 2 is 1. So what will be the sum? Sum will be 3 and it will be updated here. And for I equal to 5, in tab of 5, I will update the sum of tab of 4 and tab of 3. So 3 plus 2 equal to 5. So 5 will be updated here. And when it will execute for I is equal to 6, in tab of 6, I will update tab of 5 plus tab of 4. Okay. So 5 plus 3, which will be equal to 8, and 8 will be updated in tab of 6. And then this for loop will finish and control will come here, and this line will return tab of 6. So 8 will be returned. So this is the answer. Now let's do some analysis. And what analysis? Space complexity and time complexity. So first of all, time complexity. Here is the for loop which is running n times. That is running for I equal to 3 to n plus 1. So basically, this for loop will be of order of n. And what we are doing inside this particular for loop? We are doing some constant work. Okay? So order of n into order of 1. This is some constant operation. So time complexity will be order of n. Now calculate space complexity. And one more thing. See, time complexity here is order of n, and in recursive code it was 2 to the power n. So using DP method, see how much we have decreased from exponential to linear time program. Now come to space complexity. We are creating a table of size n plus 1. So space complexity is also order of n. I have a question for you. Can we do it better? That is space complexity. Can we improve it further? Please write your answer in comment. And if you have liked this video, then please like, share and subscribe, and thanks a lot for watching.